In the end, renal physiology can be expressed in this one sentence: creating urine to get rid of wastes, because that's why we do it, and to control the level of fluid and electrolytes, all while holding on to molecules of value. That's the tricky bit. It's easy to filter, right? You know, we do that with our Brita filters, with our Brita pitchers, right? Filter's nice and easy. The tricky bit is holding on to the things we want while we're filtering. So, how good is the kidney at that? You know, in the end, we want the kidney to get rid of all the waste products and nothing of value, right? So we can hold on to everything and get rid of all the things that are not useful. All right, so one of the ways we can sort of evaluate the kidney's performance is to compare values in the plasma to values in the urine. Essentially, it is plasma that becomes urine, right? We're at the glomerulus, we're going to filter out the red cells and the proteins, right? Everything else is going to go into the nephron. The kidney is going to do its magic, putting things in and taking things out, so that that plasma that entered, what we call filtrate, by the time it comes out of the ureter, is going to be a very different, have very different values than what went in. Okay, so let's look at some of these. Sodium. Right? Normal range, 135 to 145, that's plasma. But look at the urine, huge range, 40 to 220. Why? Because the amount of sodium we take in varies. If we have a low sodium intake day, we'll have a low sodium output day. If we have a high sodium intake day, opposite, right? So we see a variance. Same with potassium, right? Now, please remember, look at the difference in these numbers. Small numbers, big numbers, and a fairly big range. Where's most of the potassium in the body? Inside the cells where you can't see it, okay? So we have more potassium to get rid of every day than we ever see in the plasma, because in the plasma it's kept low, but we still have to get rid of it. And we see a range, because just like sodium, we have high potassium days and low potassium days. So it has to vary. Chloride, same story. Less of a variance, but still there. Okay, now let's look at some of the precious. Bicarbonate is valuable to the body, right? Because every molecule of bicarbonate is a way of getting rid of a hydrogen ion. It's a way of getting rid of pH in the lungs. So the kidney conserves it. You see that? We have a lot of bicarbonate in the plasma. By the time filtrate becomes urine, there's hardly any. We've held on to the bicarb, all right? Now, metabolites, glucose. By the time glucose is freely filtered, it's a relatively small molecule. It enters the glomerulus, but the kidney is incredibly vigorous at pulling glucose back into the blood. Why? Because it's a valuable metabolite, right? So high in the plasma, very low in the urine. Same with lipids, high in the plasma, low in the urine. Why would we get rid of precious metabolic fuel, right? Amino acids, same thing. Proteins, 0, right? The glomerular filtration membrane, which we're going to spend more time talking about than you want to, is the reason why proteins don't enter the urine. We don't want proteins in the urine. Proteins are hard and expensive to make, right? We don't want to lose them. So there's almost none there. Now, waste products. So these are metabolites. These are good things. These are solutes, good things, bad things, right? Now we can see amplification of waste products, where the urea in the plasma is relatively small. The urea in the urine is huge, highly concentrated. Why? Because that's a waste product. We want to take as much urea and put it into the urine as we can, because it's no good to us. Creatinine, same thing. Ammonia, same thing. Uric acid, same thing. So while we have small levels in the urine of good stuff, we have large levels of waste products. So all in all, the kidney gets a pretty good report card. It does exactly what we want it to do. It controls our ions so that we don't have to think about it. It holds on to the molecules we can use, and it concentrates the molecules that we don't. Because think about it like this. If your urea in the urine was 100, you would have to make 18 times the volume to get rid of the same urea, right? That's a lot more time in the bathroom than I want to spend.